Okay, so next we'll have a roundtable to talk about skills. And as you saw, I mean, I'm coming from education, and understanding like what are the relevant skills in an AI era is pretty relevant for us as a research education, as a research university. It's also relevant for young people to figure out, where to go from here. Before I do that, let me just have two announcements. The first is one thing I forgot when I promote my lab, is that if there are companies, organizations that are interested to collaborate and follow GitHub as a partner, please just email me, and we'll be happy to be in touch. I now turn more like a salesperson, selling soda and soap, but we would very much love that. The second is, so over the lunch we were discussing about differences of Europeans and Americans, and one difference is how likely you are to go up to a senior people as a student and ask questions and talk to them. And so please, I'd like to take this opportunity to encourage you guys to go, use the next break, go over to the speakers, ask them questions, ask about, promote yourself. This is the idea of the Jamboree, is this should be perfectly okay. Okay, so we are very good in time, and I think just very good. And so let's start the panel. And one-to-one mapping is the best you can get. So this is fantastic. So let me introduce the panel. Kevin, you've already seen. Annalisa Cadonna is advisory AI engineer for IBM. And Karl Kugler is head of AI Factory Austria.
Hi, nice to see you all again.
So before we start, and I'm like a useless, mediator here, or make-believe journalist. Okay, so before we go, Annalisa, can you introduce yourself, say a little bit about what you're doing, and yeah.
Yeah, so my name is Annalisa, I'm an AI engineer at IBM. In the last couple of years, working a lot with generative AI. I think I've seen some of you already. But actually, my background is more in mathematics and statistics. So I have a PhD in applied mathematics and statistics, was for a few years an assistant professor. And then naturally, when I left academia, I became a data scientist. And the type of models and skills and like the field was evolving so fast that it kind of led me naturally to become an AI engineer. What we do now is I work at IBM, so we work with our customers, and of course we kind of try to sell our products, but in general we try to help our customers to integrate generative AI and AI in general in their workflows, and try to understand exactly what problems they have, how can we help them, etc. That's me. So if you're interested in the field, just talk to me at the break.
Cool, thanks for the introduction. So my name is Karl Kugler, and sticking with the theme of leaving academia, I start with what I did before doing that. So I did a PhD in bioinformatics, was working on genomics for biomedical data. And then when leaving academia, I did not become a data scientist, but become a consultant with Bearing Point and Accenture for the last 10 years. I was also working with Luca, so it was nice seeing him again on stage. And what I did was basically helping clients do what you were talking all about this afternoon, helping clients to use data, use AI to solve their problems. And I think that's the most important message. It's all about using problems, understanding problems, and finding solutions. Like you said, how can you use data? And that's the message I was taking with me for the last 20 years.
Very good. So the first question is the following. So think about like the past year and kind of the current state of AI. And look back, in the job that you're doing, but also a little bit around you. What are the biggest changes that you see in terms of what people are doing? Kevin, you wanna?
Yeah, and I think I alluded to this in my answer to your last question, but so one of the things that I wanted to do to set up within GitHub was to create like this community of practice where we could share our kind of ideas about how to use these AI systems and to create new tooling that would be really useful for their workflows. And I had feared like, oh, maybe I'd have to try to incentivize people to try to get them to use these AI and play with them. But yeah, to my very pleasant surprise, like everyone had already been using these things and like played around with these things on their own. I guess they were, I think often we're too shy to knock on each other's doors and ask for help. But that is something that I think would be useful in this like AI age, like to be more willing to create and collaborate together and share knowledge with each other.
First, I'm so glad that this is what the lab together will be doing. But also, like, did you see people change in terms of their, what they're doing, their tasks around you? Was there any change, or they were just doing the same things, but now with a little bit of AI?
Oh, I see. Yeah. I don't think there was very much in terms of the entire like end-to-end process reorganization that Lucas spoke about. It was more about you have these piecemeal tasks that do take up a significant amount of time in their day, and they're more efficient in those tasks now, and they were to churn through more of those tasks in a shorter amount of time.
So now you work less than before?
It's just like a never-endless fire hose of events that happen each day, though, and our platform just keeps growing. So it's, I don't know, like in the end, you probably just you keep churning out more and more useful work, but often like I guess the prize for winning the pie eating contest is more pie. So.
More pie. Good. More pie or Apfelstrudel for you. Annalisa, what is your experience?
Yeah. So two things you also said. So one, workflow. So both inside IBM and outside, we saw people trying to improve their workflows, especially, of course, what is related with documents. So how I extract things from the document faster, how I write my email more efficient. So this, absolutely. I also would say, which is interesting, I saw that it was like the hierarchy was a bit more flattened between senior and junior with the advent of AI. And I think, like you said, it's people are more open. There is more of a common language now. And I also, for example, from my junior colleagues that just finished university, I also learn a lot from them that because of this common language and AI. But in general, what I would say, workflow, work a little faster, but I also haven't worked less.
So not less work, similar, but a little bit more and more efficiently, but
yes.
Not big change in the composition or in the actual work or the types of work that they do.
Well, what I also have to say that, of course, also in big company, it takes a while to make sure to have all the permissions in place for you to actually use the tool that would help you make your work faster. So, for example, in IBM, we got our first internal coding assistant, like maybe in beta a couple of months ago. And so before there were a lot of restrictions. So I would say in big companies that still, unless like either you break the rules or the adoption is taking of tools a bit of time.
Right, so going back to Lukasz's point that maybe Accenture is advising the big clients, but there's more restrictions at them, so that's the advantage of smaller companies.
So maybe all of what you just said, totally agree. To not repeat what you just said, maybe on a meta level, what I have seen the discussion about AI changing with the people I was working with. So before it was about using AI and just using the best tools, and now it has been really become a strategic asset. So how can we differentiate ourselves in Europe by using AI? What assets do we use? Do we still use hyperscaler tools? Do we use European tools? And how can we become more sovereign using these tools? So looking at you as students in here, how can we use the talent that we built in Europe? How can we train the talent that we have in Europe to build our own workflows, our own tools, our own companies, our own hyperscalers, basically? And I think that's one of the discussions I learned. So people use AI in every day, but do not only use it as a tool, but really as a strategic asset to help them become more successful in the market, but also to make the market different, shape the market, and shape also the European landscape to say, what do we need to do to become more sovereign as Europeans when it comes to AI?
So it's a little bit less within companies and more like across companies, the shift is more like that some companies are doing different things?
Also within companies. So until a year ago, there was seldom a discussion about sovereign models or running models in your own cloud, in your own environment. And for a year now, this discussion has been going on a lot in the public administration. It was always there, but now also swapping over to private companies that say, okay, I still use hyperscaler services, but for certain tasks in my company, I want to become master of my own future and want to keep my asset in a place where I can control where they are, how they are leveraged, and who can access them. So I think that's a shift in the discussion that we are seeing.
And what is the role of AI Factory Austria in promoting this?
So from my understanding, there's three things that are needed to become sovereign. One is data. So data is the key to really make it possible. So we help companies understand what is their data, what data is out there. We have the European data spaces that are now emerging, the health data space, the manufacturing data space. How can we connect research, looking at the research university here, with the application in industry? The second pillar would be compute. So we are building supercomputers all across Europe, and a bit plugging here, we have supercomputers for the last 7 years that can be used by academia. They can be used by smaller companies, by startups, free of charge. So check those out. And we are working on making them more accessible. And the third part, again, looking in this crowd here, is talent. So we're trying to foster talent that is out there. You are training people that have the skills. We need AI engineers more than ever. And now we need to bring it into practice. We need to connect them with the industry that are looking for these people, to have trustworthy sources of talent and bring the ones that need the talent together with the ones that produce the talent.
Good. So my second question is more about kind of tasks and skills. What are the, again, think about the people around you, yourself, but also, a little bit more the team that you work in or the department. What are the skills and what are the tasks that benefited the most with the emergence of AI? What are the skill sets that have become more relevant or more useful for the company? Let's start with Carla.
I think the skill set that has always been the most useful and even more important even now is to just be flexible, to have an open mind and to adapt to change. So we see so many models emerging every day, and I stopped listening to whether Gemini version X or OpenAI version Y is better, because at some point you just get lost in this model competition. So it's really about what solves the problem best for the client, for my problem, for my team. How can I adapt to the change that is necessary? How to identify the change that is necessary? So I think a certain robustness in your mindset and a certain flexibility in understanding what are the solutions that are needed are the skills that keep you safe even for the future, because you cannot run after every hype, because you're gonna get crazy, and as you said, you end up eating more pie than you can digest. So really deciding which pie you want to eat and which pie you just ignore. I think it's the key skill to really focus on what makes your career great, what makes your life better, and what to do in the end.
Yeah, similar answer also. So critical thinking, using AI as a tool, understanding how it can make your life easier, but especially in the technical field, I think it's still important to understand, right? Understand the math that's behind the model, understand actually what's happening, what is the meaning, what are the probability that are outputted, because the only thing that I'm seeing that I don't really like that much is that a lot of AI engineers then have more this role of, okay, I put together a few APIs and I get my result. So always be critical about what you're using and how it's actually working under the hood. This is in the AI engineering team or field.
So let's talk a little bit about math.
Yeah.
Right. So clearly AI is pretty good in a lot of math stuff. Same with coding. So what's the point of why should people still just to be a little bit put you on the like on the spot, like what's the benefit of knowing math? We have a math department, so I hope they will not like, they are small, but they will not like kill me or something.
Okay, so well, First of all, the way, so if I could go back, I would just study math and pure math, right? So first of all, understanding and the critical thinking behind it, right? And then when we think about AI, and so we see words, right, which actually are probabilities behind it. And the way I think about it, when I was doing classical machine learning, I don't know, there was an output of a machine learning model was a probability that we should give a loan to a person. And no, the person deciding were very well aware of what that meant, and they also were aware that they were the person making the decision using the AI. And I think we should kind of like get into the mindset that this is also what we need to do with generative AI. Know how it works, see what the output we get, and then interpret it and use it. So
less mystification and more probability theory.
And because we talked a lot about data literacy in the past few years, right? Even when we see at the news, different graphs, different plots, it's very important to have data literacy. And now I think it's very important to add AI literacy too.
Yeah. Okay, I mean, what are the skills in software or in legal that are kind of now are worth more than 5 years ago?
Yeah, so I would totally echo the points when it comes to like learning how to learn, basically. Like that ends up being extremely beneficial to your career path, much more so now because it's just so easy to get a crash course in things.
So the price of learning has come down, so now you want to use more of it.
That's right. Other thing that I would say though is that something that I mentioned in my talk earlier, like there's some useful thing about imbuing something with this human spirit that is just like personal to you and something that AI would not be able to replicate, right? Because don't have a PhD in econ, but I did attend Scott Cunningham's Causal Inference 2 workshop a couple weeks back, and one of the things he mentioned was that in a diff and diff analysis, one of the core components of this is the parallel trends assumption, right? And this parallel trends assumption, like you cannot provide any data or proof that this parallel trends assumption is in play, right? Like you can't prove it with the data because the data doesn't exist. You need a potential outcome that didn't happen in reality, right? And so all of that, you have to make your argument like with persuasive rhetoric, basically. You have to and like that kind of persuasive force, it is helpful to have kind of this human expert, because if this is something that is actually high stakes, like high cost of error, like we as society often we wouldn't accept some non-human where the buck stops, right? We want to know like this is the person who was responsible for this decision and it was well considered, well thought out, and I think there are also other tasks where it's not really about finding the correct like mathematical answer, like the outcome that you wanted. Like you had to do something that showed that a human cared about this, right? Like that's what was important. I read this recent news article about something called the soup wars that are starting in Silicon Valley, and the soup wars refers to where Mark Zuckerberg has hand-cooked soup and hand-delivered that soup to a machine learning engineer or AI researchers that he wants to poach to join his company. And like that act is meaningful because it's like him doing the thing, right? Like if he got an AI agent to like deliver it to them, like, I don't know, that's just not the same, right? Like you don't get the same outcome.
So first, just a side note on the parallel trend assumptions. You had a very good foundation, so that's very good. And so these are the you mentioned some of the what are the skills that went up? What are the skills that are downgraded? Right? What are the skills and tasks that are now worth less than before? Who wants to start?
Repetitive work, I guess that's what we are all observing. So knowledge worker that do repetitive. So one of the use cases I see the most is really like processing of documents, of mountains of documents, and this can be done much more efficiently now with AI. So which is a positive thing, right? Like we like to say, like
you classic automation,
right? The classic automation, and this is So
what are the skills that are maybe less, less relevant or less valuable than they were before?
I think, so in the way of like doing things like by memorizing things or by learning something that needs to be done in a specific order, now we really are learning, like you said, in a completely different way, right? So I would say, once again, critical thinking is up, and just reading, memorizing, and following instruction becomes less important.
What else to add there? I mean, I think that's the wave that they've seen, and that's why we see also this shift in consulting, coming from a consulting background, these classical analyst jobs where it's just put 5 people into a room for 2 weeks and wait for 40 pages to come out after that. I think these kind of jobs are less already. We see that already. But on the other hand, we see the need to really critically digest what's coming out and make it digestible for the client. So I think this translation job is still going to be needed. It's going to be different. But yeah, fast reading is probably not the skill that will make you stand out on the market any longer.
Yeah, I would agree with everything my colleague said, or fellow panelists said before. One thing that I think stands out to me is that often when it comes to so it's like these Amazon Mechanical Turk kind of jobs, right? Like data entry, it's like very straightforward point and click kind of things. I could see some situations where like the cost of error is so high and the payoff is so high that you would still have a human do that, right? But these would be situations where it's like, there's like scorched earth litigation, like you've hired this $2,000 an hour lawyer, like you didn't hire them to be efficient, you hired them to win, right? And so like just like getting guarantees on all of the inputs, even if it required hiring like 2,000 different people, hiring all these consulting firms to back up these claims in a lawsuit, like maybe those are the situations where you still have a market for that. But yeah, I agree it would be somewhat less of a demand for that kind of thing.
Okay, so my third question is, so let's assume that AI is getting better every year, but we don't have whatever AGI is. Okay, so there's every year marginal gains, less hallucination, better performance, faster, cheaper, blah blah blah. But like not the nature. We have the let's fix the current type of AI. Allowing them to become better. So many of people here are students or fresh out of school. And so if you think about a little bit longer run, so 3 to 5 years, again, no AGI, but like, what do you think are what should they do? What should they learn? What are the skills that they should develop? What should we teach more, right? So again, thinking a little bit ahead, which is always difficult, but it's worthwhile in the sense because you want to invest into think. And so what are the skills to develop? What are the new things to learn? What advice would you give, Carl?
I think Kevin said it before when he said we have to learn how to prioritize, because you cannot learn everything, you cannot eat every pie, and not every pie is worth being eaten. I think that's one important message. You really don't have to know everything, because many of the things that you are seeing hyped now are going to be forgotten in like a half a year from now. So you really have to learn how to prioritize, how to focus on what's important, and of what you learn, what to keep in mind and what to forget again. I think that's also a lesson, to really learn what to forget and what not to keep in mind. And this is going to be more critical in the future, and then also to learn on how to make an impact with what you know. I think that's one of the skills that's going to be more important, because theory alone will not be enough to make an impact. That's my lection over the last 20 years. It's good to have knowledge, but if you don't put knowledge into action, it just says knowledge and theory. But really learning how to apply your knowledge, how to make an impact, how to turn businesses around, how to reinvent businesses, how to challenge businesses, how to challenge the way you do things right now. Because wir haben immer schon so gemacht, is the German word. How to do that and when to say it and who to say it to. I think that's the thing you really need to learn, how to challenge the status quo with what you have learned.
So learning to learn, basically trying, to learn something very fast, and then the other thing is maybe more business or more practical, how to turn what you know into actionable, which is, I think, more like a business skills. So you would say more business skills.
More business or more outcome driven. So I think it's good to know the theory and to improve the theory. But in the end, theory becomes real if you put it into practice, if you test it, if you see if it works out in the real world. And I think that's where the change is really coming from. And this might be where the US is leading ahead of us. And I don't know if we have talked about that today, but I think the big difference is if you are a great mind in a US university, you think about becoming a founder, about making money, about starting your own business. For us, it's often like, I have a tenure track and career security for the next 40 years. And I think that's great because you need to drive forward the knowledge, but at some point then we need people like people in here that really then take this knowledge and put it into practice and put it on the street, put the rubber on the street and see if it works out.
Yeah, I would add communication skills, people skills, interpersonal skills are always important, and maybe now with the advent of AI, there is also less human contact, so those skills are important. And then I always like this T-shaped knowledge where you have general knowledge and understanding and know where to go and find information, but you are very specialized in a field. And I think we cannot be all generalists, so if you have a passion and a specific niche, like you mentioned, law, it's still good to really focus on one topic that you're passionate about and be the top expert in that topic. I think as much as we can, because then there is a trade-off, right? Do we tune an AI model to be a specialist in a specific field of law, or we hire the person that has already that knowledge? So I also think there is still space for specialized knowledge.
So when it comes to skills that I feel like maybe this is a hot take. I feel like there's been some discussion of this question of whether coding is still relevant to learn nowadays, and I feel like LLMs or AI it is regarded as something that it might be a GPT, a general purpose technology, right? And another general purpose technology that we've had in the past is electrification, right? Electricity. But the kind of productivity boost or any benefits of electricity didn't accrue from someone handing you hey, here's some copper wire. It's got electricity in it, right? There was something that they gave you in addition to it, or you bought it, that harnesses electricity somehow. It uses the electricity to do something else, right? To do something else useful, right? And I feel like coding is a lot of is like the harness for that technology, right? Because OpenAI they made GPT-3, right? And that was fine. But when they made ChatGPT, the UI interface to allow you to harness that for the first time, that really blew up, right? But that's not the only interface that might be useful, right? There might be many other personalized tools that you'd want to make yourself that you would know best, what would be the solution. And this also gets to a previous point where, I totally agree that a useful trait would be someone who thinks as an owner of a company, right? You as an employee, you might be tasked with some instruction to do something, and you might dutifully do it, send in a report that does exactly that thing. But you could unlock probably more value if you do it in a tactful way of saying but also this is what you should have asked me, right? And these are opportunities that we should have gone after that are totally related to this, and I can do that. This is my plan for pursuing this X, Y, and Z that would unlock whatever X billion dollars. And that's the kind of thing that I think would be very compelling to employers, and less of a the mechanical Turk kind of transaction of you do the thing that I asked you to do, and that was it, no more, right?
So what about as a university, we teach stuff, right? And I teach stuff, and they pay me to do that. And I hope they will. I mean, I have a tenure, so AI, whatever. But I want to also make sure that what I do or what we do is meaningful. So where do you see kind of the benefits of education? To be a little bit provocative here, and that's my last question before turning to the audience. You can start thinking really provocative questions. So what is the value of knowing things? I mean, you mentioned math, and I think that was a great segue. Anything you guys want to add on the value of knowing coding, the value of knowing statistics, then the value of knowing data science or metrics or...
Maybe I can add something about the value of a university teaching, about what you have learned at university. It's not so much about what you learned content-wise. You have to know it for your exams. But what I found...
Exams are important.
That's
they're important.
For these 5 years, it's the most important thing to do. But after that, what I really learned in my life, what really struck out and really helped me a lot was the structured way of approaching problems. On a university, you learn how to have a complex problem, break it down into something that's digestible. We have the topic of digestion today. So really an organized way of working, of a structured way of organizing your way, a structured way of communicating your results. I think that's the best benefit of a university education that you can get if you really learn this methodical way of approaching a problem, of educating other people about your problem, about your results. And that's something that is going to be helpful for the rest of your life, even with AI, without AI, with coding, with everything else. If you have a structured way of approaching these problems, if you can convince people that you are capable of digesting complex problems, of solving complex problems, of communicating the solution, then you have a benefit that you can take with you for the rest of your life, regardless of if it's math or computer science or bioinformatics or whatever. It's really about this mindset of, I can solve a complex problem, I can work with others, I can find a way to get it done.
Yeah, and because you talk about statistics, like one of my favorite concept is always the signal to noise ratio. And it's something that I, try to understand, to have a data-driven approach. Sometimes maybe you don't have the p-value or exactly the solution, but you need to understand, in all this mountain of information and of data and of people expressing your opinion, right? What is the signal into this? So that's statistics. I love statistics. And regarding coding, I think a good foundation on coding and understanding how it works is fundamental, right? My first exam at university was a Java class, and then, I used Java a little bit, and then once you transition in using Python, everything seems easier, right? But you still know what an if statement and a for loop is, that maybe if you started directly using Python with list comprehension, you would be confused about. So it's fun, right? So even if you then want to code only using AI, I would suggest you start learning the basics of coding.
Yeah, and just to answer my question, I mean, in some sense, this is a way to learn to think, right? Coding is not just to produce something; it's a way of expressing our ideas, and statistics is or data literacy is also important to be able to talk to AI. All right, let me stop here, and then let me open the floor to ask again provocative questions, and this is good. So let me go there first. So I think first, and then I don't know the second. No, that was. So anyway. No, there.
So you went first.
Thank you. I have a question about European data space. Carl mentioned, but any one of you can answer. And there was this panel I listened to during the summer about European health data space with Michaela Fritz. And I wanted to ask you, how can we enable use of, secondary use of healthcare data for innovation and researchers such that more people can benefit from it in an ethical way? Thank you.
That's a very, very hard topic to answer, because I think it comes down to a bigger picture that we see in Europe. So we have some of the best universities in the world. We have one of the best student-producing factories where we get great talent. We have great IP. We have great ideas. But when it comes to skepticism towards technology and against new things, Europe and also the US to some degree is leading. So if you look at AI, for example, the positive attitude for AI in China, in India is about around 70%. In Austria, Germany, Europe overall, but also the US, it's around 30%, 35, if you will. So there's a skepticism against technology, against science to some degree, that needs to be tackled first. So just take, for example, the gene regulation for green biotech, so plant genomics basically, that was just released 2 days ago. There's not so much positive attitude in Europe than it could be, because now we have really instruments to do something about food scarcity and all these topics, but all we hear in the public media is, oh my God, genomics is gonna kill us all. And I think this also leads in the topic what you said, what can we do about the secondary usage? We have to reduce the fear of using data to help people. I mean, if you remember back in Corona, everybody was talking about follow the science and data-driven approaches, and we thought, okay, now it's the time for universities and science to shine, and everybody's gonna follow the objectivism, the numbers and the science. And now we're back to these discussions about the flat is Earth or not, or the Earth is flat or not. So I think it's about skepticism, and then secondary, making useful applications for that, really show people what's the benefit of having these data spaces for health, for example. So what's the secondary usage that can be enabled, giving people a good example of why it benefits them. But it's really about this, skepticism that we see so much across Europe.
Thank you very much. I have a provocative question, right? The speed of development of AI is huge. It's hard to compete with it, and generative AI is getting better. It's improved trust into technology, so it means that people will use it more, they will trust more, and they will think less. So we increase artificial intelligence, but we decrease intelligence of humanity, of population. What should we do?
Yeah, and I think, can't remember if I mentioned this in my presentation, but yeah, like there are like good and bad uses of AI. I feel like, it's kind of similar to like, in my mind, the analogy that I go back to is like libraries, right? Like libraries are amazing places. Like you can learn so much, right? But you can also go to a library and just like copy verbatim from the answer key within that like library book, right? And you would learn nothing, right? And it is but it is much easier to just like regurgitate, to copy answers than to do the work. And maybe this goes back to Galbert's question of like, what are the returns to education, right? In law school, maybe this was just a marketing tactic, but they say like, oh yeah, the selling point is that you learn how to think like a lawyer, right? But I think that is kind of true. Like it is very helpful to know how this like brilliant law professor thinks, right? Because like in terms of like learning how to learn, like what you need to do is you're exposed to all this like input stimulus, and you have some existing mental model in your mind, and you have to construct new knowledge schemas with any like salient inputs that you receive, right? Because if you learn something new and there's nothing to connect it to you, or connect to your existing mental model, you're gonna forget it immediately, right? And sometimes I feel like AI tools can be helpful for helping you develop that knowledge schema because you have something to interact with of like, oh, like what are the demographic kind of factors that would affect changes in trends over time, right? Like that's the thing that you'd want to ask to figure out if the parallel trends of bias or assumption is valid, right? And you might not be best friends with the world-class demographers, but at least you'll be generating the questions in your mind to like engage truly with the thing rather than kind of taking it as gospel, whatever it spits out, and not engaging it with your mind. And so I think that's something that we probably should emphasize more in terms of how to interact well, usefully with an LLM to make sure that you don't just end up into more like over reliance or automation complacency, that might be termed.
Love the positive energy.
No, just to add that I think like with every technology, right, the education system, so schools, and I think we need to, we are rethinking how to teach, and then thinking about little kids which are already exposed to AI, right, family and parents, like we dealt when for smartphones came out, you need to think about how you let your kid interact with AI now, and then the school system from primary school and on.
Questions?
No, I was just challenging your hypothesis that we are getting stupider as humanity. Maybe some of us, but I would not challenge that one. But in general, I think it's like you said, with every technology, I think there's a huge benefit in it. If you look at my sons that are quite young, or my daughter, for them AI is an everyday part of their lives, and they learn to use this technology in a way that we couldn't imagine. And AI literacy is something that they just grow up every day with, and they become more savvy on this topic than we will ever be. So I am quite optimistic for that.
Around there. Oh, you want to?
Yeah.
Sure.
So you mentioned, when talking about the skills needed in the AI era, you mentioned quite a few of human qualities: interest, entrepreneurship, curiosity, just being on your toes. How do you enter the field of data science, a very wide field of data science, and prove those elements when you look at job postings that say 1 million years of experience in 10,000s of software development or languages? How can you prove these skills that you really cannot teach someone? They have it, right? So any tips on that for people who are entering the field?
Networking is a good starting point. So being here, talk to people, talk to friends in the field, being in contact with your study colleagues. I think that's one of the starting points. And I think at least when I interview people, the technical skills are just part of it. So I think a lot of companies are aware. A lot of companies write skills that are impossible to have, right? Like years of skill in technologies that are just emerging. So I think getting through the door is the hardest thing. But I think networking and speaking up, show your projects if you have done something on GitHub or so is a good way. And I think so just a shout out also for all the women here. Then that's also something that usually, like this job description, hold us back. Just apply, send a message on LinkedIn. Yep.
I was going to say building up your portfolio, just like learning in public and putting that out there to show off your critical thinking skills and your ability to provide advice that is sound and was the result of a lot of like cognitive load. Maybe that is something that should be emphasized more in our marketing materials, like interacting with an LLM and learning something shouldn't feel like you're drinking or sipping Mai Tais on a beach. Like it should feel like very painful, right? Like you are, like anytime you're learning something, like you're rewiring neurons in your brain. Like it takes a lot of energy. It should not feel comfortable, but it should, like the payoff is like new knowledge, and that should be how it feels to learn something new, and being able to express that in like a public portfolio, whether it's on GitHub or not, I think that would be a good way to showcase your ability to make sound like business decisions and judgment to any employer who'd be interested in making more money, and hopefully lots of employers would be interested in that.
And I think that's not only on the person looking for the job. I think it's also something that the employer should change when looking for people for a specific job.
And also take the chance, if you have a panel, to ask questions that are provocative so that the panelists will remember your face when you apply.
So you got a job.
So we have maybe time for one more question on the back. So we can have 2 questions and then they can go reply. So then you guys in the back first, and then second, and then.
Thank you very much. My particular concern is on domain knowledge versus technology expertise. I feel that having domain knowledge seems to be really important. Just looking at the panels, I see economist expert, I see statisticians, I see, I think, finance or something else. And while most cases, I think in the functional industries, it's really great when you have a data analyst or data scientist who is an economist or finance or sales and marketing or in these aspects. So how really, what's your advice on bridging the gap between the domain expertise and the technological strength? And as somebody who would want to hire an expert, who would be your preference? Somebody who is built on the domain strength and has added some technological component that is necessary versus somebody who focuses on building technology and most likely he doesn't have much of the domain expertise.
It's both. So it depends on the position that you want to fill. So if you're looking for someone that drives forward a technology platform, you're of course looking for someone who has technology skills and can think into the problem that's going to be solved with the platform. If you want to hire someone that can really help as a data scientist to solve a problem, then you of course would prefer probably someone that can talk to the ones that have the problem on the same eye level, on the same vocabulary. So I think it depends a bit on the position. When I started out, the definition for data science was just emerging, and I still love this definition to this day. So to me, it's always this trifectum of you have computer science because you need to scale, you need to implement a solution. You have machine learning because you need to know the algorithms, you need to know the statistics, you need to know what fits your type of problem. And then the third portion was always you need to have a certain domain knowledge in order to be able to formulate your problem, to ask the right questions when formulating your problem, to be eye to eye with the problem, with the people that have the problem. And if you have these three in combination, you have a data scientist. Was when I was starting out. There's not always one third, but this was like the theory of a data scientist. And depending on what type of role you're looking for, maybe it's someone that has more business understanding, can translate the business problem into a technical problem that AI engineers solve later. If you're more on a platform engineer level, you need to have more of a technical background and maybe not so much of a domain knowledge. So it's really what you want to do and what is being looked for and what type of company you're applying with. If you're looking for a consultancy that has a very narrow very narrow domain knowledge, you of course should have some domain knowledge for this consultancy. If you look for a generalist role in the data science space, maybe you should be broader. So I think it's not one size fits all answer here.
Anything you want to add?
Yeah, I guess I agree. I think you need both for any like credible like data analysis like work product. And so,
So I think that's a fantastic. Let me stop the questions here. We'll have. I want to keep time, so we have some wine and we have some cheese and. I just want to thank you guys to sticking out. I mean, it's been a long day. And it's like almost 7:30 on a Friday. So give yourself a round of applause. Thanks for coming. Thanks for our wonderful speakers. Thanks for the organizers. And Dominika in particular, if you are here, thanks a lot. Krista, thanks a lot. Thanks for Vienna Data Science Group for being a wonderful partner, not just for this event, but through all our programs. Thanks for the panelists. And stick around, network, chit-chat, and hopefully see you next year. Ciao.